Okay, everybody, here are the rest of the notes from Thursday. So first thing we're going to do is we're going to expand each logarithmic expression. So we're going to expand the multiplication. We're going to expand with addition. So since we have multiplication between the 5 and the x and the y, we're going to split that apart using addition. So we'll have log base 4 of 5 plus log base 4 of x plus log base 4 of y. So they all get separated with addition. If we look at B, we have both multiplication, the 4 times the w, and we have the division. Let's tackle the division first. So we'll have the log of 4y minus the log of 7. Notice this is there's no base written there, so it's the common log, base 10. And then we're going to separate the multiplication using addition. So we'll have the log of 4 plus the log of w minus the log of 7. Again, remember that multiplication and addition go together, and subtraction and division go together. And then what? Then we've got some multiplication here. So we'll split apart the multiplication pieces using addition. And then these exponents can drop down out front and become coefficients from our other rule. And so we'll get 2 times log base 7 of x plus 3 times log base 7 of y. Notice they're both log base 7s. The base does not change. All right, and then the next part, we're going to condense things. So when we condense, we smush it back together. So I always just work left to right. So if I look at the first two, we have addition. So where does addition come from? It comes from multiplication. So we'll have log base 3 of x times x. And then we still have minus the log base 3 of 4. And then what? Then subtraction. What does the subtraction go to? That goes to division. So we'll have log base 3 of x times x is x squared. And then divided by the 4, the subtraction goes to addition. Notice that when we condense it, we only have one log. Log is written only once. So here we went from 3 logs to 2 logs to 1. All right, we look here at number 2b. We've got this coefficient out front. Where does it belong? It belongs up as an exponent. I always do those first. So that gives us a log of 5 squared minus the log of 4. Then we've got the subtraction. The subtraction came from division. So we'll have log of 5 squared, which is 25, divided by the 4, again going to just one log. And then if we look at C, we've got some coefficients. Push those back up to the exponents that they were. So that'll be log base 7 of x cubed minus log base 7 of y squared plus log base 7 of z. And working left to right, we've got subtraction here. So that came from division. So we'll have log base 7 of an x cubed over a y squared plus log base 7 of z. Then what? Then we've got addition. So where did addition come from? Addition came from multiplication. So we'll have log base 7 of this piece here, the x cubed over y squared, times the z, multiply fractions straight across. So we'll have an x cubed z over the y squared. Again, notice we went from 3 logs to 2 logs to 1. Which of the following statements is not equivalent to log of 16? So not equivalent to log of 16. Well, we can take this coefficient of a 2, put it back up. So that becomes the log of 4 squared. 4 squared is 16. So that's the same. Then what? We've got this addition here. Addition comes from multiplication. So we'll have the log of 8 times 2, which is the log of 16. Not it. Here we've got subtraction. Subtraction comes from division. So we'll have 64 divided by the 4. 64 divided by 4 is 16. Not it. And then we've got this one here. We'll put the 1/2 up as the exponent. That's log of 256 to the 1/2 power. Remember, 1/2 power is really the square root of 256. The square root of 256 is really just 16. So all of these were log of 16. All of them are equivalent. They're all equivalent. They're all log of 16s. So it's just a quick practice of the rules. Remember, addition and multiplication go together, subtraction and division go together, and powers or exponents become coefficients out front. And then number 4, Chandler was asked to rewrite log base 2 of 32a to the third and simplify her work as shown below. So she starts off with log base 2 of 32a cubed, and then she splits the multiplication with addition. That's great. Then what? Then she says log base 2 of 32 is 5. So that's really asking you the question, 2 to what power is 32? 2 to the 5th is 32, so that's good. And then the next step, it looks like she took the exponent and dropped it out front as the coefficient. That's good. So step 4 is where she made the mistake. What's her mistake? She added the 3 plus the 5. Can't do that. Those are not alike. This is like adding a 5 plus a 3x. Not alike, cannot combine them. So we would actually stop there. That would be our final answer. Okay. So she made her first mistake in step 4 because she tried to combine like terms, but they were not alike. All right, and then I want you to flip over to the homework page. I wanted to look over that real quick. We've got our rules here. Multiplication, addition, division, subtraction, power becomes a coefficient. All right, so these here, expanding the logs, you should be able to handle those. Maybe check this out here. You've got a square root of x. Think of that as an x to the 1/2 power. Then you're going to condense some things, smush them back together. I always handle the coefficients first and put those back up as the exponents to kind of get them out of the way. These are the ones I wanted to talk about a little bit. Solving equations using logarithmic properties. All right, so we've solved some log equations where we got log of something equal to log of something else, and then we said, well, what you're taking the log of, those have to match, and we would solve those. Okay. If we look here, we don't have just one log over here, we have 2 logs. So we need to smush that back together. We need to condense those logs back into one. Well, we've got subtraction. So subtraction comes from division. So we'll have the log base 4 of 48 divided by x equals the log base 4 of 6. The log base 4 matches the log base 4. We've got log equals log. So what we're taking the log of, the 48 over x, has to equal the 6. Can you solve that? Sure, not a problem. Cross products, 48 equals 6x. So x equals 8. Then you always want to make sure to look for those extraneous solutions, those extra answers that don't really work. Can I take the log of 8? Yes, I can. That's legal because remember I can take the log of positive numbers only. No negatives, no 0. That works. That's a keeper. It was the only answer we had. If we look at number 8, we've got addition. So where did addition come from? Addition came from multiplication. So we'll have to multiply those two. Now this one's a little different because I don't have logs on both sides. Okay, so what we'll have to do here is we'll have to rewrite it as an exponential. We'll take the 6, pops the 2 up, equals x times x minus 9. Distribute. We get x squared minus 9x equals 36. Ooh, quadratic. So get one side equal to 0. And then we're going to factor. It's going to factor into an x minus 12 and an x plus 3 equals 0. So then x equals 12 or x equals negative 3. When I go back to the original, can I take the log of 12? Yep. Can I take the log of 12 minus 3, which is 9? Yep, so that's a keeper. Can I take the log of negative 3? Nope, you're out. So just the x equals 12 will be our final answer. Okay, so on these solving equations using the logs, you need to first of all, if there's two logs, smush them back together, condense them so you get just one log before you try to do anything. Something like number 9, you've got this 2 here, push it back up, so then you get log equals log before you set the two things equal to each other. Okay, so there's a few different ones here to practice. Again, I will not be tricky. The bases will always match, so I'm not going to try to mess with you there or anything. You got a couple true false using the log properties. Are those expressions true or false? And then rewrite a couple of these using different expressions, and that's what we did with the notes yesterday. Okay. Obviously, I'm sitting in front of you, so if you have questions, you are more than happy, or I'm more than happy to answer any questions that you have as you're working through the notes and the homework. Okay. Those of you who are taking the test right now, I hope you're doing well, and you get to listen to this over the weekend. All right. Thanks, guys. Well, we got 3 weeks left, so let's keep working hard. Okay. Thanks, everyone. Bye.